Hello, today we are going to compare two techniques of chromatography which are mainly used in laboratory analysis. What are the differences between GC and HPLC? You are suggested to subscribe, like, and share without forgetting to press on notification icon for being the first to see the article anytime newly posted. Gas chromatography and high-performance liquid chromatography are both separation techniques which have gained immense popularity in both academic and industrial laboratories. High-performance liquid chromatography has found favors in applications covering pharmaceuticals, food, life sciences, and polymers, whereas gas chromatography has a significant applications in petroleum and petrochemical industry, flavors and fragrances, as well as environmental air monitoring. A general question that comes up in your mind is how our HPLC and GC are different from each other and what factors decide suitability of one over the other. Many chemical compounds, including drugs, metabolites, can be analyzed either by gas chromatography GC or high performance liquid chromatography HPLC because both techniques function under the same basic principles of compound separations, identification, and quantification. It can sometimes be tricky to choose one over the other, but knowing what differences or what differentiates HPLC and GC can definitely help with the process. So let us highlight some of those differences and similarities for you. Let's start from mobile phase. As the name suggests, high-performance liquid chromatography uses a liquid mobile phase and gas chromatography uses a gas as carrier. Liquids are generally mixtures of solvents of compatible polarities, whereas in gas chromatography the mobile phase is a single high purity gas. If it comes to operating temperature, HPLC separations are mostly carried out at ambient temperatures, whereas gas chromatography separations are carried out at elevated temperatures which can be held at constant value, meaning isothermal, or variable as decided by the temperature program. Newer picking have extended temperature limits of high-performance liquid chromatography operation as well. Let us compare two techniques vis-à-vis the nature of compounds. Gas chromatography separations are mainly carried out on compounds ranging in molecular weight up to a few hundreds. Such compounds separate on differences in volatilities and remain stable at high temperatures. That is the reason why we have said at the beginning that GC or gas chromatography is suitable in separation of petroleum fraction, meaning petroleum industry. On the other hand, compounds separated on HPLC have high molecular weights ranging from a few hundred or to several millions for large polymers and biomolecules. Such compounds can be analyzed at room temperature only because at elevated temperature they tend to be uh, decomposed or they tend to degrade. If it comes to column dimensions, liquid uses as carrier as carrier in HPLC generally have higher viscosity in comparison to gases used in gas chromatography. This results in increased column back pressures in HPLC. It is for this reason that High-performance liquid chromatography columns are much shorter and have wider diameters in comparison to GC columns which have or which can be much longer and narrower. Increased column length improves the resolution between spaced peaks. At the trend is toward as the trend is towards faster analysis, columns used for HPLC are as short as 1 centimeter in length. If it comes to column packings offer a greater resistance to flow of liquids in comparison to gases. Gases also have a higher permeability of solid supports than liquids. The retention modes of HPLC columns depends on polarity differences or molecular size, whereas GC separations are based on differences in the volatilities of compounds. Let us talk to the comparison based on detection principles. HPLC detection is commonly based on non-destructive detection such as UV, RI, photodiode, array detectors, conductivity, and laser detection. On the other hand, gas chromatography detection is based largely on destructive principles such as FID, NPD, and FBD. Mass spectrometry detectors common to both liquid chromatography and gas chromatography are destructive in nature. What happens to resolution in two techniques? If your sample is a mixture, bear in mind that resolution, which is a measurement of how well two peaks are separated, is affected by a number of factors. But it comes down to how similar the partitioning equilibrium between mobile phase and the stationary phase for the two compounds. The more comparable the partitioning equilibrium is, the higher the chance of having co-erosion. If this happens, you may not be able to see where one peak ends and the other peak starts, so the resolution would be poor. Since GC separation is based on compound volatility, similar molecular weight can result in comparable retention times and cause the peaks to overlap. In the same way, the polarity of molecules affects resolution in HPLC and also the composition of the mobile phase. So we are going to compare the two techniques based on cost of operation. Generally, HPLC solvents are costly in comparison to gases used for GC analysis. In addition to cost of solvent, the maintenance cost of high-performance liquid chromatography system is also higher due to higher pressures developed in pumps and columns. GC analysis in comparison is less costly and there is lesser maintenance cost. Both HPLC and GC are versatile and have contributed to the ever-increasing scope of applications. Tandem techniques such as LC-MS-MS and GC-MS-MS have expanded the limits of detection to new frontiers of detection, and automation has also contributed to increased in laboratory throughput. Remark: Always keep in mind that both HPLC and GC are invaluable advancements in analytical instrumentation and indispensable in many scientific fields, but they are also susceptible to issues and limitations. Common problems are related to selectivity, sensitivity, and resolution, and these are affected by the nature of the sample, as we have said at the beginning. So when deciding between the two, it's really not a question of instrument superiority, but the effectiveness of the sample of interest. My advice to you is to evaluate the sample based on factors described in this article, and also weight your options with as much information as you can get. And now it's up to you to make the final decision. Let us try to see the comparison based on peak response. Both GC and HPLC chromatograms look similar. The response is peak-shaped in both cases, and the concentration of eluting compounds is proportional to the peak height or peak area. Principally, four methods are used for quantitative estimation both in HPLC and GC. Those are normalization of peak areas, internal standard methods, external standard methods, and standard additions methods. They are softwares which are common for HPLC and GC. Most manufacturers supply common HPLC and GC application software as peak analysis and data treatments are common. This is a big benefit if the systems are procured from the same manufacturer and multi-user license multi-user licenses are obtained. Such software also help the analysts to set up operational parameters and methods sequencing. Here are some examples of some software provided by reputed suppliers. Those are, for example, Perkin, Elmer, Totochrome, Agilent, ChemStation, EZ-Chrome Edit, Thermoscientific, Chromiron, and so on. Finally, to conclude, we have seen the comparison between GC and HPLC. We have compared based on sample. We have seen that the sample for GC must be volatile, low molecular weight, stable at high temperatures. For the case of HPLC, you have seen that the sample must be volatile or not, low or higher molecular weight, stable at room temperature, and soluble in liquid phase. For the case of resolution issues, we have seen that for the case of GC, it is of similar molecular weight, whereas for HPLC, we have seen that resolution issues is of similar polarities. For the case of columns, we have seen that GC column is long and narrow, packed capillary. We have seen that column for HPLC is short and wide compared to GC. For the case of mobile phase, we have seen that for the case of GC, the mobile phase is a pure inert gas, no gradient, and with no pressure. For the case of HPLC, we have seen that mobile phase must be solvent mixture of gradient and pressure required. If it comes to optional detectors, we have seen that for the case of GC, optional detectors which are mainly used are FID, hydrocarbons, TCD, universal GCMS, and mass spectrometry, whereas for the case of HPLC, optional detectors are UV, light absorption, LID, universal LCMS, and mass spectrometry. We have also talked about relative costs, where we have seen that GC is of low cost compared to HPLC. We have also talked about application of age techniques based on suitability. We have seen that GC is suitable for oil, plant pigments, pesticide, fatty acids, toxins, petrochemicals, air sample, drug abuse testing like cocaine. For the case of HPLC, we have seen that is suitable for inorganic ions, polymers, sugars, nucleotides, vitamins, peptides, proteins, lipids, tetracycline analysis, etc. For more readings, you can access the following links. The first is Agilent Technologies internet site, available at http://www.home.agilent.com. You can also access Dionex Corporation internet site, available at http://www.dionex.com. You can also visit Saperco Aldrich internet site at http://www.sigmaaldrich.com. You can finally access also the Lincoln Water Corporation internet site, available at http://www.waters.com. So, are you going to run your sample on HPLC or fly it through GC? You are suggested to give us your view and suggestion in the place reserved to comments. Thank you.